Hey everyone, welcome to the Falco maintenance track. Let's start by presenting ourselves. I'm Leonardo Grasso, and here with me there is another Leonardo, Leonardo Di Giovanna. We are both Falco maintainer. We also both work for Sysdig, and we are both Italian. If you want to reach out to us, please feel free to contact us on GitHub or Slack. We can find us on the Falco channel on the Kubernetes Slack. So, I have been involved in the Falco project since 2020, and was answered many times this question: what's Falco? So I asked myself what I could say this time. You know, Falco during the years become very popular, and I'm a bit lazy person, you know, as many engineer. So this time I just asked ChatGPT, what's Falco? Of course, ChatGPT knows very well what Falco. Falco is the open source and cloud native security tool. It was donated to the CNCF. It's nowadays a standard for runtime threat detection. It's a graduate project. But maybe you can understand more about Falco by looking at how it works. And this time I asked Gemini, of course. From an high-level point of view, it's very simple. It captures events from the Linux kernel. There is also other data source that can be added to Falco by using plugins. I just won't mention this now because during this presentation we will not talk too much about plugins. Then it evaluates this event against a set of rules. And if any of these rule matches, it sends an alert. It's very, very simple. Of course, to achieve this, Falco ships a default set of rules, but you can create your own rules, of course, to customize it for your own environment or use case. And since LLM are very good to create code, but they are very good also to create Falco rules, this time I asked Claude. And surprising, I asked a rule that I used in a demo a lot of time ago, and it created a similar rules at the first try. The rules is very simple. I just asked, can you draft a simple Falco rule to detect when the webcam of my laptop is being accessed? And by the way, this is not a mock-up. If you download the presentation that you can find on Sched, you will find the link attached to the original Claude chat. Okay. At this point, I started enjoying asking questions to AI. And so I asked to AI to answer to the ultimate question of Falco of security, the universe and everything. Does anybody know the answer? The answer is Falco 0.42, the latest version Falco that we released in October. So let's see what we released in this version. There were two main features. One is the first one is the capture recording feature. I will talk about it in a while. And another one that is mostly a huge performance improvement regarding the drop enter initiative that my colleague will speak later. Other than that, we also introduced a more strict validation on the event schema produced by the plugin. We also introduced an option to fine-tune how Falco can clean up the thread table, which is part of the state that Falco construct when it's running. And last but not least, we also introduce a very simple feature requested by the community that gives you the possibility to add some static fields to any rules. These fields must be defined configuration time, and those can be useful in the case you have some information on the host that must be shared alongside to the events. So, let's start by talking about the capture recording feature, the last major feature introduced in Falco. As I told before, Falco has some rules. This is an example of rules. But until now, when a rule triggered was just the end of that flow. The rule triggered and that's it. Now, with this feature, we introduced the possibility to record into a file. We call those files SCAP files. All the events starting from when the rule is triggered up to a duration that can be defined by the user. We introduced the possibility to do this for all the rules. So in the case any rules triggers, a file is recorded, or only for specific rules. We also introduced the possibility to customize the duration of this recorded on a per rule basis, as you can see. What happened? Basically, each time a rule configured with this option trigger, Falco creates a file. You can configure the path of this file, and the file is stored. The most important thing of doing this is for stuff like troubleshooting, but also for forensics analysis. And at this point, you might wonder, how can I open this file? Of course, the first option is you can use this file with Falco itself. This can be very useful in troubleshooting or if you want to fine-tune your rules. But there is another, in my opinion, much better opportunities. That is a new tool called StratoShark. This was created by the author of Wireshark. Is basically the same UI of Wireshark, how you can see, with the only difference that this tool is able to visualize capture made by Falco. It's very simple. You can, of course, you can filter, you can do a lot of stuff, and it's very useful. We already get a lot of positive feedback about this. What else? If you want to know more information about StratoShark, you can find them on stratoshark.org. And now, let's talk about Drop Enter Initiative, please.
Yeah. Hi, folks. Now I'm going to talk about the Drop Enter Initiative. That is an initiative that led to big performance improvements and at the end of the day to the removal of enter events that Falco used to generate. Let's first talk about how all begins. Basically, Falco used to generate two event types, an enter event and an exit event. The enter event capturing the syscall context before syscall processing, and an exit event capturing the syscall context after the kernel processing. These provided maximum details and flexibility, and besides other things, with this mechanism, we were able to enable talk-to mitigation in Falco. So thanks to the presence of enter events. But as Falco matured and the rule set expanded, we realized that the few pieces of additional information that enter events could provide could be consolidated into the corresponding exit events. and also reducing the amount of events that we generate could be beneficial in terms of performance, especially in high core count machines. So based on these insights, the project consolidated the syscall reporting to only emit exit events. So we got rid of enter events, and all of these that I'm discussing now were consolidated in the proposal, which you can find a link to in the bottom left corner of this slide. And of course, you need to download the deck if you want to access it. And the proposal was approved this year in February 2025, and work started since then, and it finished in October with the release of libs 0.22. But I would like to discuss with you some of the challenges that we encountered, we as contributors. And in this context, I would like to say thanks to all contributors that made it happen. The first is event data consolidation. As I said, we strive to provide the same kind of information needed to let the Falco machinery works and to not subtracting anything to the Falco detection capability. And so we made this huge work of moving the few additional pieces of information from the enter events to the corresponding exit events. As I said, this was a pretty huge task, a lot of months spent on this, but we did it. I'm very proud of this. Yeah, the second big point is talk to mitigation. Falco already provided talk to mitigation in older versions, but in the newer version, we faced the challenge of removing enter events and still provide the same set of capabilities. So there is no much to say about this. We still generate some few enter events only for the vulnerable system calls that are really affected and that's been proved to be affected by this kind of attack. But these events are only generated and used internally, so they are not exposed anymore to the final user, and so you cannot, you will not need to write any more rules regarding enter events. This machinery is all handled internally. And one of the final point is that we wanted to keep SCAP backward compatibility. You know, SCAP is a format already discussed by Leo, which encode events, and it is used for troubleshooting, for example. And of course, we wanted to provide backward compatibility for old SCAP files, so files still containing enter events. And so we built a SCAP converter layer that is able to take this information from the enter events and use them to extend the corresponding exit events. As a final note, and this is important, I would like to say that we strive to minimize as much as possible the amount of user-facing changes. But as you can imagine, we have deprecated the concept of direction because we don't have anymore the enter events and exit events. So this is the only notable piece of, let's say, user-facing change that we did. We deprecated the concept of direction and the field event here, but the good news is that your rule will continue to work, just you will receive a warning if you use this, and in order to remove the warning, just remove this from your condition and everything will work as expected. In this slide, we consolidated the outcomes of this initiative. The system call latency in workloads instrumented by Falco is up to 20% lower, or I would say even more in ISIS call environments. And the Falco CPU usage is up to 30% lower or more. This is, I guess, I think, a big result. And from a development point of view, what we got for free is that we now have a leaner and cleaner code. Now the processing pipeline is way simpler, and so I would say that the development cycles will be faster. Okay, now let's start a new section of this talk, and I would say that as community insights have been crucial for the project evolution, we would like to start with you a discussion for what could be possible areas of intervention for performance improvements or possible maintainability improvements of the project. The first thing, I will start by talking about performance opportunities. So I will start by talking about event loop optimization. First of all, what is the event loop? The event loop is a mechanism in Falco that Falco implement to get information, get events from the driver. A driver is, for example, the modern eBPF probe or the kernel module. These are simply ways of capturing information from the system. These events are passed to the upper layers of Falco. Here you can see libscap and libsysp that are basically two libraries used by Falco, internally used by Falco, and developed under the Falco security organization that provide the state enrichment, and they also maintain they also help in maintaining an internal state for Falco to reason about the new events that it receives and to evaluate rules, so to generate alerts at the end of the day. So here you can basically see the simplified architecture. And as I said, this is the event loop, and the event loop, please notice, that can run for millions of events per second. So optimizing this is crucial in terms of performance. And the first thing that we already have in place is some sort of filtering. And we would like to discuss with you after this presentation, or maybe in the Falco channels, how we can push it further. As I said, we already have some sort of filtering, and it is a kernel-side filtering. We have a light form of filtering because, differently from other tools, Falco is able to load hundreds of policies without affecting too much the performance of workloads, and so provide an heavier form could impose overheads on this workload. But we are still open to some form of different kind of kernel-side filtering. Another possible event loop optimization could be implementing multi-threading in this loop. This loop is run as in single-thread mode. And this is there are performance reasons for this. Of course, since we need to run for millions of events per second, using multi-threading can introduce some sort of synchronization penalties. But I guess that we can engineer this in a way that can introduce performance improvements on large core count machines. The next opportunity is, I would say, the fancy one. we have a mechanism called the procfs scan in Falco, and this is used both at Bootstrap to build the initial state and during the event loop. So this, in some sense, is related with the previous topic. And the mechanism in the event loop, basically, it is used to get some data, some missing data, to enrich the internal state that Falco maintains. procfs scan is just procfs scan, you know, the file system that is exposed by the Linux kernel. And we would like to replace this with eBPF iterators. That is a newer feature in the kernel. It has been around for a few years, but we would like to include it in Falco. And since we want to reach feature parity among all the drivers, we would like also to implement a similar mechanism in the kernel module, which is basically simply exposing one device and provide a synchronous mechanism to harvest tasks and files to patch the state, the internal state of Falco. So this could be a possible lighter and faster alternative. Okay, and in this other section, this is like a feedback section, but it is related to maintainability, to the maintainability of the project. And I would like to discuss one of the aspects that has limited us in implementing the eBPF iterator I was talking about. And this is the legacy eBPF probe. This is one of our three main drivers that we maintain, and we strive to maintain feature parity for these three drivers. And the legacy eBPF probe has been around for a while. And first thing that you can notice from this slide is that this is the kernel coverage matrix. And the first thing that you can notice is that with the kernel module and with the modern eBPF probe, we already provide full coverage starting from kernel 2.6 on the majority of architecture. And I would say also that kernel version 5.8, which is the bare minimum for running the modern eBPF probe, has been around for a while. I would say 5 years. Yeah, it's 5 years. And but also we are aware of some distributions that already provide the feature to run a patched kernel, backporting the features needed for running the modern eBPF probe on older architecture. So I would say that now it's time to think about possible deprecations of the legacy eBPF probe, since it is not adding any more value. And it is limiting because we don't have, for example, a similar mechanism to eBPF iterators that I mentioned before. So we would face challenges in implementing feature parity. Okay, and this is another aspect that we could rethink. As for the legacy eBPF probe, we are aware that from the download metrics, we know that this kind of output is little used. We already asked to the community, and very few people uses it, and this imposes a burden in Falco maintainability, because it has to ship all the dependencies on gRPC framework that in C++ is a big dependency, and it also increases build time. So there are possible alternatives. We could move this gRPC output to Falco Sidekick, or we can even think to create a new plugin API. I don't know, we could call it output plugin API and enrich the plugin system, or we could even think to deprecate it. As always, we will ask for feedback on this topic again. And as the last thing, there is the gvisor libscap engine. As you may imagine, this is used to ingest events from gvisor, but again, we are aware of the fact that this feature is a little used, and it is a sort of a driver for us, so we need to implement feature parity also among these and the drivers. So we would like to understand if the community still need it. We could think about deprecation or also to refactor it as a plugin, as a source plugin in this case. Okay, now it's time for feedback. So if you have any question or any feedback, this is the right time to step in. Okay, I guess there is no question, so we can go to the next slide. Yeah. If you want to provide a feedback or you have any issue or you want just to reach us, you can contact and discuss with other Falconers on the Falco channel in Kubernetes Slack, and also you can contact us on the CNCF Falco dev list. And every 2 weeks we have a community call, so please feel free to reach out to us. Of course, you can always come to the Falco project kiosk number 13A at the Solutions Showcase to say hi in person and share some times with us. Okay, thank you.
Thank you. Thank you.